Welcome, my dear student. This is A. Venkadeshan, Assistant Professor, Department of Mathematics, St. Joseph College of Arts and Science, Autonomous Cuddalore. In this video, we're going to see regions in the complex plane. Before we go to this video, once again we recall the last videos. In the first video, we display what is complex plane and some properties of complex plane. And the next one is further properties: modulus, vector of moduli, sum of complex number, triangle inequality, and generalized cases. And after that, roots of a complex number, and so. So now you enter the major level of the complex plane. So we're going to see only the definitions of the following. So that is deleted epsilon neighborhood. That is, what is deleted epsilon neighborhood? Interior point, exterior point, boundary point, open set, closed set, domain, region, and accumulation point. So first definition. So what is epsilon neighborhood? A set of points in a z plane satisfying the inequality the mod z minus z naught is less than epsilon, where epsilon is greater than 0, is known as epsilon neighborhood of z naught, or otherwise the set of points which in the circle mod z minus z naught equal to epsilon is known as epsilon neighborhood of z naught. So what does it mean? If you are taking a point, so from that point we can draw a circle with some radius. Suppose if possibly we draw a circle with 2 radius, means that 2 is here epsilon. So we draw the circle with the 2 centimeter, means around the 2 centimeter within the point is a neighboring of the z naught. So next thing, deleted epsilon neighborhood. A set of points in the z plane satisfying the inequality 0 less than mod z minus z naught less than epsilon, where epsilon greater than 0 is known as deleted epsilon neighborhood of z naught. So the last one is, we know what is epsilon neighborhood. So this is deleted epsilon neighborhood. So first of all, it is epsilon neighborhood. By addition, we say one condition. So what is that condition? If you have seen it, that is the set of points which in the circle lying inside but not a circle centered at z naught, which is known as the epsilon neighborhood of z naught. So the epsilon neighborhood, we know epsilon neighborhood means from that origin we choose the neighboring point. Here deleted epsilon neighborhood means you should not take care about the center point. So we know the floppy disk. It is the best example for the floppy disk. So next definition. Interior point. A point z0 is said to be interior point of a set S if there exists at least one neighborhood completely within S. So the set of all interior point is known as interior of S. Suppose if you take any point, every neighbors, any point, so at least a person having a complete neighbor within the set. For example, we can take a point from 2, that is center point is 2, and we draw a circle with the 2 centimeter. So within this point, having a infinite number of points within the circle. So in this one, so we draw the circle with 1 centimeter distance from 3. So if you draw 1 centimeter distance with the circle means, so all the point of neighbors of 3, it should covers within this the 2 centimeter circle. So like that, if interior of mod z equal to 1 is, mod z should less than 1. So exterior point, a point z0 is said to be exterior point of the set S if there exists at least one neighborhood of z0 lies completely outside S. A set of all exterior points is known as exterior of S. That is, exterior of mod z is equal to 1 means if mod z is greater than 1. Next one, boundary point. A point z0 is said to be boundary point of S if every neighborhood of z0 contains within S and outside S. A set of all boundary point of S is known as boundary of S. Open set. A set is open if and only if each of its points is an interior point. The next definition is closed set. A set is closed, it contains all of its boundary points. Closure of the set. A set is said to be closure if it contained S and its boundary also. Next one is connected set. An open set S is said to be connected if each pair of point Z1 and Z2 in it can be joined by a polygonal line. So within the set, we take any point, that point can be connectable, means we can say that set is connected set. Next one is domain. A open set which is connected is called domain. The next definition is region. A domain together with some none of its boundary point is referred to as region. Accumulation point. A point Z0 is said to be accumulation point of a set S if each deleted neighborhood of Z0 contain at least one point of S.